Welcome everyone. Today we're going to be talking about multiplying radical expressions. So last time we talked about adding and subtracting, and today we're just going to talk about multiplication. So our only objective is to multiply radical expressions. So let's do a little review first. We're going to need this property that we learned yesterday called the product property, so let's review what it is. The product property states that the square root of a times b equals, or is equivalent to, the square root of a times the square root of b. So the way we're going to use this today is kind of to go backwards. We're going to flip it. So we're going to take the square root of a times the square root of b and convert that to the square root of ab. Let's see this in action. Okay, our goal is to multiply radical expressions, and we're going to do this by using that product property of radicals. So this is product. All right, and our first example is square root of 3 times the square root of 6. This we're going to combine into one radical by flipping our product property. So this is going to be the square root of 3 times 6. And 3 times 6 is 18. So we have the square root of 18. We are not done when we get to this point, because at this point, we can now factor this into something with a perfect square. So 18 is 9 times 2. So let's rewrite this as the square root of 9 times 2. And let's use that product property the way that we first learned it, where we kind of separate this. So we can separate this into the square root of 9 times the square root of 2. We all know the square root of 9 is 3, so we're going to get 3 square root 2. And since 2 is prime, we can't do anything with it. It's not a perfect square. We are done. So our answer is 3 square root 2. In example number 2, we have 5 square root 2 all squared. So with this one, I would recommend writing it out. Remember that little saying we had, when in doubt, write it out? I would do this for this. So I'm going to have 5 square root 2 times 5 square root 2. That's what squaring is. So now I'm going to want to multiply both of these together. So I would recommend multiplying the numbers outside of the square root together and the numbers inside of the square root together. So let's separate these. So we're going to get 5 times 5 times square root 2 times square root 2. See where those came from up above? Now we know 5 times 5 is 25, so we can do 25. And with our product property, we can combine these two. So we'll just have one radical of 2 times 2. Now 2 times 2 is 4, so I'm going to get 25 square root of 4. And going backwards again, square root of 4 is 2, so I'm going to get 25 times 2, which equals 50. So 5 square root 2 squared equals 50. All right, let's do another. Okay, in number 3, we have 3 things multiplied together. 2 times the square root of 8x times the square root of 4x. So I have 2 square roots here. I can use my product property on these. So I'm going to get 2 times 1 big square root of 8x times 4x. 8x times 4x. And 8 times 4 is 32. So I'm going to rewrite this whole thing. I can't forget about the 2 at the beginning. 2 times the square root of 32 times x squared. That's x times x. All right, now we can split this up. We know 32 is 16 times 2, so this is 2 times the square root of 16 times 2 times x squared. Now let's use our product property and split this up. So we'll get 2 times the square root of 16 times the square root of 2 times the square root of x squared. Square root of 16 is 4. Square root of x squared is x. So I can take some of these out. I'll have 2 times 4 times, and now I'm going to rearrange these because in math, we always like to have our equations look elegant. So we want to have our square root terms at the end. So I'm going to pull this x squared and take its square root, x, and place it there, times the square root at the end, square root of 2. Can't do anything with the square root of 2. So now I have 2 times 4, which is 8. So my final answer is going to be 8x times the square root of 2. That's our simplified form. All right, in example number 4, I'm going to have to do a little bit of distributing. So remember our distributive property? If we have something on the outside of parentheses, we can distribute this to both of our terms. So I have square root of 2 times the quantity 5 plus square root of 12. So I'm going to rewrite this with all of my distributions here. And I always like to write my square roots last. So I'm going to write 5 square root 2 instead of square root of 2 times 5, plus square root 2 times square root 12. Now, with using my product property, I can rewrite this guy over here on the right. So I'm going to get 5 square root 2 plus 1 big square root of 2 times 12. 2 times 12 is 24, so I can rewrite this again, 5 square root 2 plus the square root of 24. And now we kind of want to break this up into something with a perfect square. So 24 is 4 times 6. So I can write 5 square root 2 plus the square root of 4 times the square root of 6. Notice I kind of skipped a step here. I already used my product property on this. I didn't have to write 1 big square root and then split it into 2. If you are having difficulty with this, I would recommend writing it all out. Take as much time as you need to get that practice down. So I have the square root of 4, which is 2, so I'm going to rewrite this again, and I have 5 square root 2 plus 2 square root 6. Now remember, I can't combine these because they are not like radicals. So at this point, I'm done. This is my simplest form. All right, let's do one more of these type. Okay, number 5, another distribution one. So I have the square root of 3 times the quantity square root of 3 minus square root of 5. So I'm going to do my distribution here, and I'll see square root of 3 times the square root of 3 minus the square root of 3 times the square root of 5. Oops, 5. All right, square root of 3 times the square root of 3, I can put in 1 big square root, so that's 3 times 3, minus 1 big square root of 3 times 5. That's all my product property there. And this is going to be the square root of 9 minus the square root of 15. Square root of 9 is just going to be 3, so that's going to be 3 minus the square root of 15. And I can't do anything with the square root of 15. 15 can't be factored into any perfect squares. So I'm done here as well. All right, let's look at something a little bit different. Okay, so this part is a little bit new, but also a little bit old because you have definitely done this before. We are going to use FOILing. So remember what FOIL stands for? First, outside, inside, last. We're going to use that with radicals. So here we have two expressions multiplied together. So we have 4 plus the square root of 5 times 3 minus the square root of 5. So I'm going to do first, outside, inside, last. And just a little tip, this is what I like to do when I have negatives in my expressions. I like to underline that negative with my term so that I make sure to multiply the negative through. Otherwise, it can sometimes get lost in the shuffle. So let's do this out. First, I have 4 times 3, which is 12. Then I have last, 4 times negative square root of 5. So that's minus 4 square root of 5. Inside is square root of 5 times 3. And remember, we like to have the square roots after our numbers. So that's going to be plus 3 square root 5. And then square root of 5 times negative square root of 5. So that's going to be minus square root of 5 times square root of 5. All right, let's rewrite this a little bit simpler. So we have 12. That's our only number. Then we can combine these terms because they have like radicals. So negative 4 square root of 5 plus 3 square root of 5 is going to be negative 1 square root of 5. I'm just going to write it as negative or minus square root of 5. This part I can make into one radical with my product property, so I have the square root of 5 times 5. I can rewrite this again. I have 12 minus square root of 5 minus the square root of 25, and the square root of 25 is 5, so I'll rewrite this down here. 12 minus the square root of 5 minus 5. And since I have two numbers, I can subtract those, and I think I'll have my final answer. So 12 minus 5 is 7, and I can't forget my radical here, so 7 minus the square root of 5. That is my final answer. Let's do one more of these and then we'll be done. Okay, here I have 1 plus 3 square root of x times 4 plus square root of x. So I'm going to write in my first, outside, inside, last, and let's multiply this out. So 1 times 4 is 4, and then my outside I have 1 times the square root of x. I'm just going to call that plus square root of x. I don't need the 1. Inside is going to be 3 square root of x times 4. And if I do 3 times 4, I get 12. So this is going to be plus 12 square root of x. I multiply those numbers together, but I can't touch what's inside the radical. Finally, the last here is going to be plus 3 square root x times square root x. All right, let's write this out a little bit simpler. So I have 4, that's my lone number, plus I have the square root of x plus 12 square root of x. Those are like radicals, so I can combine them. I'm going to get 13 square root of x. This part, I can use my product property on, so I'll get plus 3 times the square root of x times x. Let's rewrite this again. So we have 4 plus 13 square root of x plus 3 times the square root of x squared. The square root of x squared is just x. So as 4 plus 13 square root of x plus 3x. Now technically we are done with our math here, but if you want to be mathematically elegant, we can place these in the correct order. So we can reconfigure this to have our x terms first, our radical terms second, and our constants third. So we'll have 3x plus 13 square root of x plus 4. You wouldn't get points off or anything for not putting it in this form, but technically it's how mathematicians would write it. All right, with that, I will leave you to try those problems at the bottom of your guided notes, and I will see you soon.